Hello students, welcome back to the subject fluid mechanics. We are learning unit number 2 fluid statics, and today is the lecture number 4. So in previous few lectures we have discussed about hydrodynamic bodies, which is our submerged bodies and its behavior. That part we have already discussed. Now today we are going to start with the new concept, that is buoyancy and floating or flotation. Myself Praveen Yachada, I am assistant professor in mechanical engineering department. So we have discussed about when any body is submerged in a liquid, either in vertical direction, horizontal direction, inclined direction or curved surface, the total pressure force P acting on it is same, and its value is WA x bar, where x bar is nothing but the depth of immersion with respect to its center of gravity G, A with the surface area of the body, and W is nothing but the specific weight of body. So that part we have discussed in the first lecture, or previous 2-3 lectures. Today we are going to discuss about buoyancy and flotation. The objective of today's lecture is to know about the buoyancy and flotation and to know about Archimedes principle, on which this concept is dependent. After end of this lecture, you will be able to explain buoyancy and flotation. You will be able to explain about Archimedes principle, and again you will be able to solve some problems with respect to these above principles. So, what is buoyancy? Whenever a body is immersed completely or partially inside a fluid, it is subjected to an upward force which tends to lift it in upward direction. So this tendency for an immersed body to be lifted up in the fluid due to an upward force opposite to the action of gravity is known as buoyancy. It is known as buoyancy. So you can see at here, this object is partially immersed in the fluid. So it is floating over the fluid due to the one upward force, and it is coming downward or immersed inside the liquid. It is due to the weight of object. So the opposition force which creates oppose to the object or weight of object to immerse inside the liquid is called as a buoyancy force. So the force tending to lift up the body under such a condition is known as buoyancy force or force buoyancy or upthrust. Sometimes it is called as an upthrust also. So it is dependent on the Archimedes principle. What is Archimedes principle? Archimedes principle states that when a body is partially or fully dipped into liquid at a rest, when the body is partially or fully dipped into a fluid at rest, the fluid exerts an upward force of buoyancy equals to the weight of displaced fluid. So, if the force of buoyancy equals to the weight of liquid, the solid will remain in equilibrium, and this is called a flotation. This phenomenon is called as a flotation. So, that phenomenon can be explained with this help of this figure. Suppose this is a container. Up to this opening it is filled with the water, and the object is kept above the liquid surface. Now here the object is going to be lowered into the container of water. When a half portion of container is immersed inside this container, half portion of this wood plate is immersed inside this container, the amount of water is displaced due to the volume of this strip inserted inside the water. When it is completely immersed in the body, in the water, then the amount of volume of this plate is equals to the amount of volume of water which is displaced through this container and coming to this small flask. Comes to this small flask. So this is the Archimedes principle, states us that when a body partially or fully dipped into the liquid at a rest condition, the fluid exerts upward force 100%. When it tries to insert in the liquid, some upward force is acting on it, and the amount of buoyancy for upward force of buoyancy equals to the weight of displaced fluid. Okay, so this is the Archimedes principle. Now, what causes the buoyancy force? What is happening due to the buoyancy force? The buoyancy force is the upward force on an object exerted by the surrounding fluid. So, when an object pushes water or fluid, any fluid, since here I have taken the example of water, so that's why I use the analogy as a water. But objects, when an object pushes water, the water pushes back with as much force as it can. So, if the water can push back as hard, the object will float, and if not, it will sink. It will sink. So, here in the figure itself, you can observe that a kind of ship is floating over the water of a very big size, with a very big weight due to the buoyancy force in a vertically upward direction, whereas a small rectangular box of a steel will dip inside the water or sinks inside the water due to the less amount of buoyancy force with respect to its weight. Or in your childhood you may have played with some instruments like where if you apply the air pressure through the whistle knob, then ball is floating, and if it is stopped, then ball will sit down over the opening of your whistle. So that is again the cause of buoyancy force. Now, what is meant by center of buoyancy? It is defined as the point through which the force of buoyancy is supposed to act, is known as center of buoyancy. The point through which the force of buoyancy is supposed to be act is known as center of buoyancy. So suppose this is the boat floating over the water, and this is the amount of submerged area which is submerged inside the liquid, and this is the center of gravity of this particular area, CG. Then the buoyancy, center of buoyancy is nothing but the CG of this submerged portion. The point of application of the force of buoyancy on the body is known as center of buoyancy, and it is always the center of gravity of volume of fluid displaced. Okay. Now, based on this, we will see some examples. A wooden block of width 1.25 meter, depth 0.75 meter, and length 3 meter is floating in the water. The specific weight of wood is 6.4 kilonewton per meter cube. Then find volume of water displaced and position of center of buoyancy. Now, this is the wooden block immersed inside the water. The total height of wooden block is depth of wooden block is 0.75 meter. The total width is 1.25 meter, and it is floating over some area is floating over the water, and remaining is inserted inside the water. Let the point G at where W with the weight acting in downward direction. Let PB be the buoyancy force acting at point B at the center of gravity of the immersed body acting in upward direction, and let H be the height up to which it is submerged. So, and the length of wooden block is 3 meter. So, total volume of block is B into D into L. So 1.25 into 0.75 into 3 is nothing but 2.812 meter cube. So total volume of block is 2.812 meter cube. Now specific weight of wood W is given as 6.4 kilonewton per meter cube. So it is nothing but 6.4 into 10 to the power 3 Newton per meter cube. And therefore specific weight is nothing but weight divided by volume. So weight of block is nothing but specific weight into a volume. So the total weight of but specific weight is nothing but W is equals to rho into G, and therefore weight of block is nothing but rho into G into volume. Now here volume is known to us, specific weight is known to us. So multiplying by it, we will get weight of block is nothing but 18 into 10 to power 3 Newton. 18 into 10 to power 3 Newton. Now weight density of water is nothing but 1000 into 9.81 Newton per meter cube. So weight of block is 18 into 10 to power 3. Weight density of water is nothing but 1000 into 9.81. So volume of water displaced is equals to weight of water displaced divided by weight density of water. So it is nothing but 18 into 1000 divided by 9.81 into 1000. So it is equals to 1.835 meter cube. So amount of water displaced is equals to 1.835 meter cube in terms of volume. So the position of center of buoyancy can be calculated by considering the volume of wooden block in water is equals to amount of water or volume of water displaced. So now from this here we comes to know that since the amount of volume of water displaced is less than the total volume of total volume of block. The total volume of block is 2.812 meter cube, whereas volume of displaced water is equals to 1.835 meter cube. So therefore, by considering that, we comes to know that some portion of block is above the water. Now to calculate how much amount of body or up to which height the block is water block is immersed in the water, we use the formula volume of wooden block in water is equals to volume of water displaced. So volume of wooden block in water is nothing but 125 its width into L3 meter into depth unknown value is H is equals to 1.835. So H can be given as 1.835 divided by 1.25 into 3. So H is nothing but 0.489 meter. So amount of portion of or amount of height of block immersed inside the water is equals to 8.49 meter, and hence the center of buoyancy is nothing but H by 2 and it is nothing but 0.244 from the base. So from here the buoyancy point B is located at the distance of 2.44. Sorry, 0.244 meter. Okay. Now this is one another problem. A metallic cube of 30 meter side, 30 centimeter side and weight of 450 Newton is lowered into a tank containing a two fluid layer of water and mercury. Determine the position of block at mercury water interface when it was reached at equilibrium position. When it is reached at equilibrium position. Okay. Now consider this figure. The metallic block or metallic cube sinks inside the water surface and comes to the mercury at the water mercury interface. As per the principle of flotation, we know that weight of liquid block is equals to amount of buoyancy force. Weight of liquid block is nothing but amount of buoyancy force. So it is amount of buoyancy force, or it can be again written as weight of water and mercury displaced by the block. Buoyancy force is nothing but weight of water and mercury displaced by the block. So weight of the cube is equals to nothing but, we know that specific weight into volume. For cube purpose, weight of cube is nothing but specific weight into a volume. Now we know the total weight, it is nothing but 450 Newton. The specific weight is nothing but rho into G. So it is 1000 into 9.81 into about water. The total height of water is H1. So H1 into 0.3 into 0.3 because it is cube having the same side diameters of 0.3 meter plus amount of mercury which is displaced is 13.6 into 1000. That is 13.6 is the specific gravity of mercury into 1000 is the standard wet density of water into 9.81. It is the specific gravity into H2 into 0.3 by 0.3. Now H1 equation will be developed in the form of H1 and H2. So H1 plus 13.6 H2 is equals to 0.509 meter. Call this equation as 1. And we know that the total height is H1 plus H2 is equals to 0.3 meter. So comparing equation 1 and equation 2, H2 can be calculated as H2 is equals to 0.01658 meter. So the block amount of depth of block immersed inside the mercury is 0.01658 meter. And opposite to that, H1 will be calculated as 0.3 minus 0.01658. So H1 can be calculated by that formula. The next is the stone weight 392.4 Newton in air and 196.2 Newton in water. Compute the volume of stone and its specific gravity. See, weight of stone in air is 392.4 Newton. Weight of stone in water is 196.2 Newton. Now for equilibrium condition, weight in air minus weight of stone in water is nothing but weight of water displaced. Total amount of water displaced. So the weight of stone in air is 392.4. The weight of stone in water is 196.2. So the difference between them is 196.2 again, and then it is equals to the weight of water displaced, and weight of water displaced is nothing but weight density into volume of water displaced. Weight density is nothing but 1000 into 9.81 and volume of water requires to be calculated. Therefore, volume of water displaced is equals to 196.2 divided by 1000 into 9.81. So it is equals to 2 into 10 to the power 4 centimeter cube. So volume of stone is equals to 2 into 10 to the power 4 centimeter cube. Now the specific gravity of stone is nothing but mass of stone is weight in air divided by G. So it is mass of stone is equals to 40 kg. So density of stone is equals to mass in air divided by density of stone is equals to mass of air divided by volume. So 40 divided by 1.50 meter cube. So it is nothing but 2000 kg per meter cube. 2000 kg per meter cube. And therefore specific gravity of stone is nothing but density of stone divided by density of water, and it is equals to 2.0. Now one more problem. A body of dimensions 1.5 meter by 1 meter by 2 meter, weight 1962 Newton in water. Find its weight in air and what will be its specific gravity. This problem again similar like to the previous one. Here the volume of body has been given. It is equals to 1.5 into 1 into 2 is nothing but 3 meter cube. Weight of body of water is given. It is 1962 Newton. Now the volume of water displaced is equals to volume of body. So total amount of water displaced is equals to 1000 into 9.81 into 3 is nothing but 29,413 Newton. Now from equilibrium of the body, weight of body in the air minus weight of body in the water, weight of water displaced is equals to weight in water. So it is equals to W into air. So weight of body in the air is nothing but 31,392 Newton. Now mass is equals to weight of divided by G. So it is nothing but 31,392 divided by 9.81. So it is nothing but 32 kg. 3,200 kg. Now density is nothing but mass divided by volume. So density can be given as 32,000 divided by 3. It is equals to 1066.67 kg per meter cube. Now specific gravity of body is given as weight density of body divided by weight density of standard fluid, that is water, and it is equals to 1.067. So this is about buoyancy force and floating. One more point in a floating and metastatic weight we are going to discuss in a next lecture. Till we will stop at here. Thank you.